This is Cori Delano.
Hello, today I'm going to be talking about ibuprofen. I chose this molecule because it's very common and it is something that most people have taken. And so the common name for this molecule is ibuprofen, but we can also call it 2,4-isobutylphenyl propanoic acid. In this case, the propanoic acid group appears here. Of course, the phenyl is here, and then the isobutyl group is this right here. But if you didn't want to reduce it down to the isobutyl, you could also call it 2,4,2-methylpropylphenyl propanoic acid. And in this case, the methyl group is here, the propyl group here, phenyl, and propanoic acid. Okay, so to determine if this is a chiral molecule, we need to see if there's a carbon that has 4 different constituents attached to it, and we can see that there's actually only one chiral carbon in this molecule, and it's this one. So there's also, of course, a hydrogen attached here, so we have 4 different groups. Now we want to see if these are just the same molecule or if they have enantiomers. So what I've done is drawn the molecule in its mirror image. So as you can see, these are mirror images to each other. The H is coming out and the CH3 is going back. So let's label the constituent groups. So coming out from here, we have carbon on each of the first atoms. So let's go out one further. So here we have oxygen, from here we have another carbon, and from here we have a hydrogen. So hydrogen's gonna be the lowest priority. It's gonna be 3, oxygen's gonna be 1, and this is gonna be 2. So here we're gonna have it going in the clockwise direction, but because the hydrogen is coming out at us, it's going to be S. Let's do the same over here. So again, it's going to be 1, 2, and 3. This goes in a counterclockwise direction, but because the H is pointing out at us, it's going to be the R conformation. So these molecules are in fact enantiomers, and they are not the same molecule. What I thought was really interesting about this is that ibuprofen is used for inflammation. A lot of people take it for headaches or aches and pains, but the only biologically active ingredient in it is the S conformation. However, the pills like Advil come in 50-50 ratios of S to R conformation. So really only half of the pill you're taking is biologically active. And I thought this was cool because it's such a small change, but makes a really big difference.